lecture here on introduction to NS3 architecture. So first, directly what I do is NS2 already many of you might have heard about NS2. So NS2, it's there from 1998 up to 2011. The time frame is only for just 12 years. But 2015 onwards, we have a tool called as NS3. So before that, it was under development. So now it is almost matured. And now NS3 focus mainly on C++ and Python programming. So if you are comfortable in C++, we can go into C++. If you are comfortable in Python, we can go into Python programming. So it is a discrete event simulator, like most of the network simulations, they were all discrete events. So it is everything is based on a finite number of events. So one event, packet sending is one event, packet receiving is one event, plotting the results is one event. So everything is based on the discrete set of events. Actually, NS2 and NS3 both were from the same university. So same university have done it. So whatever NS2 models were, they just imported into NS3, or they reused the modular programming into NS3. So whatever you do, the performance in NS2 can be equally be done in NS3 as well. So it is NS3 is a new simulator, but some of the models were ported from NS2 to NS3. So now I have just given operating system, Ubuntu virtual machine image I have just given you. You can make use of that, because most of the times installing the software will have a tough time. So to avoid that, I have created a VM image, so that VM image can be used by all of you. So the VM image, since we don't want to restrict only to the paid participants, whoever register for our workshop, we have given the VM image. So if they wanted to use, they can also use. So we have already shared it. I'll just show you how that VM image can be done. I mean, after the explanation gets over. Okay. So we can use in Windows also, and we can use in Linux as well. So in Windows, there is a separate process or procedure there. I'll be showing you that also, because in my machine, I have in Windows, I have in Linux, everywhere I have this NS3 installed. I'll just tell you how to do that. So again, shortly by tomorrow, we'll give a manual also. So manual means exercise number 1, experiment number 2, 3, 4, like that. We are in the preparation of this manual. So we thought of giving at the end of the 5 days only. But anyway, if I give tomorrow, then at least you can have a flavor of working out before the session gets over. So that's why we will be giving a manual also tomorrow. Whatever we see, we document it and give it to you. So NS3. It works with the Windows, it works with Linux perfectly. In Windows, we have one module called as Windows Subsystem for Linux. Generally, we call it as WSL. So I'll just show you. So in Linux, we use in Linux, generally Linux. And in Windows, we use one module called as WSL. So WSL means Windows Subsystem for Linux. So this also we can able to use NS3 here. So these are the two things. So we have already sent one VM image. So the VM image has already been shared. Anyway, I'll just share that in the text window also. If you want, you can download both this, this operating system. So this is where NS3 have a support on this. Increase the font. So day 1 FTP. Okay. So NS2 versus NS3. So NS2 uses OTCL and C++, whereas NS3 uses only C++. So only if you know how to read a code, how to understand a code, it's fine. Because now it is a chat GPT era where the codes can be generated through artificial intelligence, and we can able to directly use those codes. But I have tried for NS3 using chat GPT and Google Gemini, but many of the times the codes were not working or are not compiled properly. Maybe I'll show you a demo also. So even for if the code is not working, to make it work, you should have some basic knowledge on how NS3 is operating. So it is a fundamental thing that everyone has to know. Whenever you see the code, what is this code? You need to understand that. So that kind of programming knowledge is there. It's a prerequisite for this understanding. Okay, and we have many tools with NS3. So you can see some of the tools here. So these many tools are there for NS3. So we need to have Wireshark. Then we need net anim, network animation. We need trace metrics for analyzing ASCII trace, and we need ASCII trace files that will be generated from NS3. We have packet capture files. We have flow monitor to handle the packet flows, and we have GNUplot for plotting and visualizer. So visualizer is a bug, so it is not been used because we use netanim. So visualizer we need not use. So these are some of the tools that we can able to do. So in the first 2 hours of session, I'll show you everything here so that you can at least whenever you feel, oh, I can do this work. So like that, you have a clarity on how to use these tools. I'll be showing you that. Okay. So now this is how the way NS2 and NS3 were. So NS2 was just still in many of the countries, NS2 was still being used, but NS3 now they are migrating, and there are so many difficulties in NS3 as well. Because of this difficulty, many students or research scholars they refrain themselves in coming into NS3 because NS3 can able to solve many of the world's problem today. And anyway, we will see how we can able to do all these stuffs. Okay. Now, these are the 5 abstractions that we see in NS3. So you just please understand these 5. What is a node? What is an application? Channel, networking device, and topology helpers. So your entire NS3 was categorized into these 5 abstractions. Okay. So abstraction means these are the sum of set of classes that's available in NS3. NS3 is completely an object oriented. So NS3 is an object oriented. So abstraction number 1 is node. Number 2 is channel. Number 3 is application. Number 4 is net device. Number 5 is topology. Generally helper classes. Generally we call these are helper classes. So these are the 5 things that you need to know about NS3. Okay. So what is a node? What is a channel? What is an application? What is a net device? So topology helper. Okay. So now generally when we see in a blind model, a node means a computing device. Generally we call a node means a computer is a node. So we call the node as a computing device. Channel means a communication path between the nodes. Generally we have 2 nodes, node 1 and node 2. If you want to establish a communication path between the 2 nodes, then we call it as a channel. So the channel can be a wired channel or wireless channel. Wireless channel means no physical connectivity will be there, but we have some medium access control. It deployed in one node and medium access control deployed in another node. So both can able to exchange packets via wireless medium. So that is we call channel. That is wireless channel. Wired channel means we have Ethernet communication and we have Ethernet, then we have optical fiber, and there are many acoustic fibers. So we have many kind of wired communication is possible between 2 different nodes. So node is generally a computing device. Channel is the communication path established between the multiple nodes. Application means what kind of application run in node number 1 and what kind of application run in node number 2. So maybe node 1 can be acting as a server and node 2 can be acting as a client. So in that case, a server application is running in the node 1 and server application, client application is running in the node number 2. So for that, I define some application. So generally, not only this application, this is one application. Another application is UDP echo server or a streaming server. So all these things we call it as an application or HTTP application or SNMP application. So that's what we call as an application. So a node talks to another node via a communication path, which we call it as a channel. And the node uses an application called as HTTP application, which is running on either of these nodes. So that's what we call application. So net device means networking device. So networking device is a combination of software and hardware. So every node needs one address. Okay. So address means on what IP version 4 address we run it. So generally for net device, we need address. So generally we need IP v4 or IP v6. So we need some addressing. So net device is nothing but a networking device that we can able to set the address. Not only that, we need the subnet mask also. Subnet mask. So how do we do the subnet mask? 255.255.0.0. So something we do in the subnet masking. For all these things to be done, we need the net device. So this is where we have this net device. Okay. So finally, topology helper is nothing but all other classes comes under the topology helper classes. So if you want to use AODV, if you want DSDV, if you want to use DSR, if you want to use TORA, if you want to use any other protocol, I mean RIP, the routing information protocol. So for all these protocols, we call something called as the helper classes. So everything comes under this topology. So these are the 5 different abstractions available in NS3. So node, channel, application, net device, and topology helper. Whenever you see the source code having these names, you can immediately understand that, okay, this is telling about node, this is telling about channel, this is about application. Like that, you can able to fix it up. So that's what here we have the abstraction. So this slide, it's very important for you to understand what are the different abstractions in NS3. Okay. So now we have just explained it here. So what is meant by a node? What is meant by application? You can see some application is UDP Echo Client and we have UDP Echo Server. So we have a Echo Server application and we have a Echo Client application. So this also we can be able to use in our program. I will be showing you on program and how we can able to use that. Now channel is, you can see the channel what I used here is CSMA channel, point-to-point channel and Wi-Fi channel. So we have 3 channels here. We have used here. For example, these are the 3 classes that is used in NS3 on CSMA channel. I mean, some of the examples here for channel. CSMA means carrier sense multiple access. So that means what? A channel will be there where multiple nodes can able to compute for a resource, a destination node. In that case, it's a carrier sense multiple access. So that means multiple access will be possible. And if one node want to send packet to another node, it can able to send the packet in the bus. The bus will select which is the where's the destination, and accordingly it will be sending. So during this time we have collisions there because multiple packet hit each other. We call it as collisions. So this way we can use the CSMA channel as one of the carrier sense multiple access channel. Point-to-point channel means only between 2 nodes we can able to have a point-to-point connection. So node 1 will be there and node 2 will be there. If you have a physical connectivity between these two, we can establish a point-to-point connection. Wi-Fi channel means it is spread across a frequency spectrum. So if you see frequency, so in Wi-Fi channel, for example, let me write it here. Wi-Fi channel. So the channel properties means if we say 802.11, so that's what we have a Wi-Fi standard. So now we call A, P, G, N, AC, then AX, now BE. Now this how the way the standard gone. So now we have the recent thing is Wi-Fi 6 and now Wi-Fi 6E. So these are the standards what we think about. Okay. So this is in what way they use the frequency of operation is 2.4 gigahertz, then 5 gigahertz. Now we are going towards the 6 gigahertz frequency spectrum. So that means, so this how the way. So 2.4 gigahertz have some good range, but 5 gigahertz and 6 gigahertz less range. So that means, but powerful connectivity will be there, but the range will be less. Suppose if I have a router in my next room, if I use a 5 gigahertz, then my connection will be very less enough. But if I sitting in the same room, I have a very good powerful connection, high bandwidth I can able to use. But 2.4 gigahertz, I have a low data rate, but I have a good range. Means even after the third room, I still get a good connection, but the bandwidth I can have a limitation there. So this is what this Wi-Fi, these channels. So if I want to establish a networking like this, for that I need to select which MAC protocol I can use, what kind of mobility model I can use. Suppose the nodes moving here and there. So how I can able to position my nodes. So all these things comes under this Wi-Fi channel. So we have channel parameters. So I'll be showing you where the channel parameters you can go through it. Okay, what is the gain? What is the transmission gain? And what is the L factor? What is the frequency that we set up on? Everything we can able to configure for each of these channels here. So first thing is the node, and second thing is application, third thing is channel, and fourth thing is a net device. You can see the net device is, we have a point-to-point net device, CSMA net device, Wi-Fi net device, and see Wi-Fi net device uses Wi-Fi channel, point-to-point channel uses point-to-point net device, and CSMA net device uses CSMA channel. So CSMA net device uses CSMA channel. So this is how the way it works. So for each of these channel to work, we need to have the networking device. So it is something like a Ethernet card, the what we have behind our desktop, inside our laptop. Okay, so that's what we have. So nowadays laptops, they don't come with the Ethernet, but they have come with a Wi-Fi. So that means internally there is a Wi-Fi hardware is available to make your device to access as a Wi-Fi. So that hardware is nothing but the net device. So how do I model the hardware in simulation is the NS3 has answer called as net device. So generally what we do is, generally we call network adapter for Wi-Fi, which is in the hardware. But if you want to use the software for that, I can call the net device. Net device is a software model for handling the actual hardware. So this is the net device. So it's an answer for NS3. Okay. So anyway, all these things, whenever I say you may be blank, but after I show you the source code, you can understand, oh, this is the purpose. I am just writing the net device. Okay. So what I do is I'll be explaining the complete source code of it, how we can able to use. Then you can able to understand how really this things works. Okay. Okay, so now this is the net device what we can able to use, and finally we have topology helpers. So topology helper means all the protocol stack, then MAC address, everything that deals other than all these four classes we call the topology helpers. So topology helper means everything else is in NS3. Okay, so this I know I'll share the presentation also, and we will go into the modules now. Okay, now having said these basics, now theoretically if you go through it, you can there are so many things are there, but let us go into how we can able to use our a demonstration. Okay, the first session is demonstration, but please I expect that as I already sent you a mail saying that there will be no quiz or no exams at the end of fifth day. But we expect that those who attend this FTP, you please go through with some exercises what we give. So we are giving some exercises and simple exercises. We'll tell you the source code and we ask you to modify something. Only when you do that, you will have the good understanding of how this NS3 works. Okay. So now let's move into the demo. Okay. So anyway, this is recorded. I'll be giving you the complete video also. So that you can understand later also you can able to check it. Okay. Now first thing is I already shared one Google Drive. Okay, so this is my Google Drive, the Ubuntu 22.04.rar. I just shared it. So this comes around 10 GB. Okay, so already I have just downloaded that as well. You can see here. Yeah, 10 GB. So 10.3 GB I have just downloaded. Just 2 hours ago, morning only I downloaded. So this is my office. I did this everything in my home. So I just downloaded. And after downloading it, I just unzipped it here. So where I unzipped is, okay. So this is where I unzipped Ubuntu 22.04. So here I just unzipped. Okay. So this is the place where I just completely unzipped it. You can see the size of that is 33 GB. So total size is 33 GB. So this way you can have 33 GB. Then, okay. So first thing is I give the steps also here. Step one is install Oracle VirtualBox, preferably. Else you can install VMware Workstation Player. So any one of these things you can use, either install Oracle VirtualBox or you can use VMware Workstation Player. Okay. So Workstation Player now the version is 17, I think. So you can use player version number 17. So Workstation Player is free for academic use, but it's only paid for professional and any other commercial applications, but you can use freely. But Oracle VirtualBox is completely free. So it is open source and completely free. So now first I go into this Oracle VirtualBox. Once you do this, you have this website. Okay, Oracle VirtualBox. So just open this. Here you can see that you have VirtualBox 7.0. Click it. Now it will be asking you what is the host you have. So host means my host operating system where I am going to install. In my case, I have Windows because I am just running my Windows OS. You can see I'm just running my Windows OS. And Mac OS means it is Mac and Linux is this. So I am running in Windows host. So click it here. You can download. You can see the VirtualBox you can download and you can install it. I already done that. I've just done the installation. Now what I do is, first thing is step one downloaded. Step two is install. After installing and download the VM image provided to you. Okay. So, and unzip it. Unzip it. So, this is 10.3 GB. And unzip will take 33.3 GB. So, the unzipping will take 33.3 GB. Okay, unzip it. So, now I have unzipped it in D drive. Okay. So, and again, just give that use D or E drive. Do not use C drive, C colon. I'll just tell you why. Okay. Now, in my OS, you can see that this PC can see. You can see here, D drive is 80 GB free, and here 67 GB free, and here it is 90 GB free. Okay. Because C drive is in a different hard disk, and D and E in different hard disk. That's why this GB free. So whichever have highest free space, use that particular drive. But prefer not to use the C drive. Okay. By default, it will show you a C drive, but don't use that. Okay. Now let me open it. Okay. Now here is a procedure to open it. Step 3. So open VirtualBox and do the installation. It's not installation, just use a machine. Okay, now I'm just using VirtualBox. Okay, so this is Oracle VM VirtualBox. I'm just opening it. Okay, now this will be, this is how the way the screen looks like. Okay, now first there are two options there. First thing is add, or you can use new or add. So anyone is there. So I just go with a new. Okay, so virtual machine operating system. You can see the name of the OS is I am using Ubuntu _ 5G _ 6G. I give a name, or 5G 6G. I can give a name like this. Folder, you can see it is giving in C colon. By default, it gives in C colon, but don't give C drive. I just click other, and then I select the D drive. So this PC, D drive, I create one folder. Okay, D drive will leave it as it is. Select folder. So now I'm just doing the folder in D drive. ISO image, don't do anything now. And the type is Linux OS and 64-bit. So let it be as it is. Don't give select an ISO image, because if you want to install from the first time for the new OS, you can select ISO, else don't select anything. Click next. Okay. Now base memory, the RAM is 2 GB and number of processor is 1 CPU it is given. So actually I have a 12 CPU machine with the 16 GB RAM. Okay. So I am giving 2002 GB. Let it be 2 GB. Instead of 1 CPU, I give 2 CPU. Okay.
Pradeep sir.
Yes, ma'am.
Can you please confirm with us, because I feel it you're fast.
Okay.
Can we install it along with you, or what, sir?
No, ma'am. I'm just telling you now.
Okay.
Because else it will take so much amount of time.
Okay.
I'm just showing you, ma'am. Just I'm from the beginning.
Okay.
So click new.
No, we can install it later, or we can just see what you're doing.
Ma'am, first you see this, ma'am. Maybe after the break. So after 12 o'clock, we have 2 hours break now till 2 o'clock. That time you can try it.
Fine, sir. Fine, sir.
Yes, ma'am. Yeah. So Ubuntu 5G, 6G. And instead of C drive, I just go there and select other, click the D drive. So in D drive, select folder. So D drive and Linux Ubuntu 64-bit. Click next. Okay. Now the base memory is 2 GB RAM and processor is 2 CPUs. Okay. Now here there is a take around. So give 2 GB RAM. If you have total 8 GB RAM, we have total 8 GB. Sorry, 8 GB RAM. But 1 GB, if you have 4 GB RAM in your machine, in your computer. Okay, so it depends. 2 GB or 4 GB you can give. And even for 16 GB RAM, I can give 4 GB also. No issues here. But let me refrain with only with the 2 GB. Okay. And processor is give 2 processor. 2 processors. Okay. In some cases, you can give 1 processor. 2 processor or 1 processor. Or 1 processor. Okay. So this way you can allocate the resources. So this is the resource allocation. I'll just come back here. So 2 GB I've just given and 2 CPUs I've just given. Click next. Okay. So now it is asking for a hard disk, virtual hard disk. Create a virtual hard disk now. Use an existing virtual hard disk and do not add a virtual hard disk. Now in this case, click the second option. So this is very important. This screen is very important. You can click the second option because I already gave you a virtual hard disk with the 10 GB or what I have given. That is your virtual hard disk. So click empty, click it here. This icon, you have to click it. Once you click it, nothing is there. You click add. You click add here. Once you add it, you go to the D drive where I just unzipped it here. So here only I just unzipped the Ubuntu 22.04. Double click it. The first file where Ubuntu 64-bit, you are having this file now. So this file you select it, open. After selecting it, the actual size, it will be showing you 33 GB. Already we have done it, this 33 GB. Okay, click choose. So once it is chosen, you can see that use an virtual hard disk drive. The total size allocated is 40 GB. So whenever I created as 40 GB disk. Okay, among that 33 GB is already used, remaining 8 GB free. So this is for the Ubuntu virtual hard disk. Please remember, this is very important step here in the virtual hard disk. If you click new virtual hard disk here, it will be empty. So you'll have completely everything will be empty. So don't do that. Go for a existing virtual hard disk file. Then click next. After that, it will be showing you what option you have selected, what is the machine folder, everything it will be showing you. You can have everything here and click finish. Okay. So now my OS is done here. Okay. Now my OS is coming here, powered off. But it says that it is powered off. Now double click it. I'm just clicking it here. Okay, you can see. Now my Ubuntu file, the OS is opening.
Professor, in
Yes.
Ubuntu, what is the version you are going to install, Professor? This Ubuntu?
Sir, version. I used Ubuntu 22.04.
Okay, Professor. Okay.
Okay, now I just that also I'll just make a note of it. So here, what I used here is Ubuntu 22.04. This is what I used this year. 22 means 2022, 4 means April. So 2022 April month it was launched. So it is one of the long-term support.
LTS. Okay, Professor.
It is a long-term support LTS. So always go with the LTS because other versions support only for 9 months, but long-term support will be supported for 5 years.
Yes.
So now if you have a paid model, they can support up to 10 years also. But free version, 5 years, it have a support. So 5 years support is there. But for LTS. Okay, so I'm using Ubuntu 22.04. Okay, so now see that my OS got booted up here. Now this is how the way my OS is up and running. Okay, so right click, you can see I have a terminal. So I have the OS here. Now let me show you the folder. I've just opened the folder. You can see here I installed all the softwares. So NS all-in-one 3.38, which is the NS3 with 6G. This installed, and the NS3 millimeter wave new handover. So this is for 5G. And Net Simulator, this is one kind of visualizer, a 3-dimensional visualizer for flying net for drone. If you want to see how a drone is flying, you can able to see on the Net Simulator. Then we have trace metrics. So we can run trace metrics here. And the Contiki NG is installed here. So all the softwares installed here, I have just given how to install also. I have given the installation procedure also there. So we have everything available in this bundle of packages. This is what you are also going to work on. I am also going to work on for the next 4 or 5 days. Okay. So because if you want to install this, the first 3 days we have to struggle for installation alone. So to avoid that, the VM will be helpful for you. So even if you want to give it to your friends also who is working on this area, you are free to give this OS. It's completely free. Okay. So now let me check it on small programming. whether it is working or not. So what do I do is I click from the beginning, I'll go. Okay. Now this is what the left hand side window. Here I click it. Then I select terminal. Terminal, you will get a terminal gets opened. Okay. So now in this terminal, the password, in case if it is asking, the password is 123456. Let me put that also. The password for the Ubuntu OS is 123456. And username is Pradeep Kumar. So this is the username and password is 1234. But whenever the OS is booting up, it never asks you a password. But whenever you want to install something, it will ask for the password. That time you have to use 123456. This is the password. Okay. So, but username here is Pradeep Kumar. Okay. Okay. Now here it is. This is what my username. So if you see pwd, if you use the command pwd, you can see this is my home /home/Pradeep Kumar. This is my home folder. Okay. And we have the list of files here. NS all-in-one 3.38. Then NS millimeter wave new handover. And now let me go into 3.38. So CD NS hyphen all-in-one. So see, actually, whenever you want to type something here, you need not type like this. NS hyphen all-in-one hyphen 3.38. Like this. This is also one method to type it. Or first, what you do is first few letters NS I am typing and put a tab 2 times. 1 time, second time. Now it will be telling you 2 folders with the same name starting with the NS. Now this has a hyphen here. Now you can see this is a hyphen. So click hyphen and put a tab 1 more time. It auto completes. So instead of typing the full sentences, you can able to use the tabs. Okay. So use tabs tab for auto completion in terminal. Linux terminals. Okay. Right. So now this is how the way it ends. Then again, when I go into NS, you can see here there is a thing called as NS 3.38. And here we have something called as network animation, netanim. So these are the 2 folders that we have. So one is netanim, another is NS 3.38. So these are the 2 folders within all-in-one. So all-in-one means everything in one package NS is giving. Inside that we have 2 folders. Main folders that we need is NS 3.38. Another is network animation 3.109. Okay. Now clear is to clear the screen. Now what I am doing, I am going with the netanim. So type NE and put a tab. See NE and put a tab, it auto completes. Okay. Now this is netanim. You can see here the green color in this, the green color file indicates it is an executable file or called as a binary file. Okay. So this is a netanim which is already installed. So if you want to run this netanim, you have to use a command called as /. Okay, let me write that. To run any file with green color in Linux is to use a /. So the command is /netanim. So this is the command here. So // means current directory. // means it is current directory. So in the current directory, I have one file called as netanim. Use that and then put enter. Okay. So this is a simple command here. So now you can see here clear /netanim. So once I do that, the network animation window gets opened. Yes, you can see this is the network animation window. Then the file, you can open the file and then what is the animation file we can able to do. Anyway, we'll do all these things later. First, I'm showing you what software is already there inside this NS3. Okay, so this is one window on netanim. So we have to go inside this folder. Okay, now I use pwd. To make it and to make you to understand, what I do is to open netanim. Here are the steps. Okay, so what you do is Open a new terminal. Open a new terminal. Then cd ns hyphen all in one hyphen 3.38 slash. The folder name is netanim hyphen 3.109. Netanim hyphen 3.109 slash. Then this command. Okay. So a window gets open. Okay. So this is one thing on netanim. We will use on netanim. Okay. Second thing is, after that, if you want to come out of one folder, cd space dot dot. If you do that, one folder up, we just come. So the same way in Windows also we have this. One folder will come up. Okay. Now again I put ls. We have ns 3.3. Now this is one of the important folder we ever have in ns3. So cd ns hyphen 3.38. So when I put ls is listing the files, all the files and folders. I am just listing it here. You can see here, I have all the files here. So we have build, we have bindings, we have contribution. So this is one important thing we'll see. We have contrib and we have examples. We have scratch where we write all the files we store here and then we'll run it. And source. Source means already the existing libraries, pre-compiled libraries are available in the source directory. All the source codes relevant to your research will be available here. SRC. And this green color means they are executable file. So we can execute directly using /. This ns3 and this test.py. Forget about the test.py. This is very important for us. This ns3. Okay. We'll see that. Now, before that, we go into the source. What are the different source directories available and how we understand it? So src, cd space src. Now, once you go here, now this is where your research comes here. Okay. Now, antenna, AODV. Now, let's say, okay, I'll just clear it. You can see here, antenna means if you want to do something relevant to antennas, so the antenna level source codes will be available here. Then AODV protocol source codes are available here. Application source code, bridging, bridge repeaters, routers, relevant codes will be here. Bright is a university specific source code. Buildings, if you want to design buildings for three-dimensional animation, you can use these buildings here. Click is a software router and CSMA. CSMA layout. Core means it is on networking core, like the core libraries, like what are the different things on networking, switching, routing, then packets, then applications, everything is available here in the core, the networking core. Then DSDV, then DSR, then energy, then this net device. You can see the net device here. Then flow monitor. This also we are going to see. Then internet relevant source codes. Then internet applications. Then low data rate WPAN. WPAN is wireless personal area networks. If you want to work on ZigBee and WPAN, you can be able to use LTE. Long-term evolution, it is on 4G. 4G networking, LTE is there. Then mobility is there. Mesh networking is there. MPA is multi-processing interface is there. Then netanim is there. The networking related there. Then OLSR, I don't know what is this we are writing. So OLSR protocol, open flow for software defined networking. Then point to point. Then propagation, if you want to use propagation layers, like what are the different propagation loss model, propagation delay model, those people they can able to use. 6LoWPAN, it is for Internet of Things, 6LoWPAN. Spectrum, if you want to deal with various spectrums in communication, you can use the spectrum here. Then statistics, this is on bridging, some kind of bridging. Then topology, here traffic control. Then virtual networking device, visualizer. Wave is vehicular environment. Wi-Fi and WiMAX. So these are the different source codes available for NS3. Okay. So this is where our NS3 source codes have been written. So we can able to use the source code or we can able to modify the source code. Whichever way we like, we can able to do. Okay. Now let me come out of the source. We have something called as contrib, CONTRIB. So contrib means contribution, external contribution. CO contrib. And I'm in contrib now. Now you can see here, I have net simulator is one contribution. Another is a TH is a TH is nothing but the TerraSim for 6G. sixth generation, we use something called the terahertz simulator. Generally, in short, we call it the TerraSim. This is where I compiled it. I compiled the TerraSim is a third-party software. I compiled it for NS 3.38 and I just make it work. Okay, this is the THZ compiler. Okay, now when I want to see what is the THZ contains, you can see everything contains a document, some examples, some helper classes, otherwise we call topology helpers, some models, results, and some test. So these are the different folders available on each and every application. Now the terahertz also, it contains like this. Okay, so if you see model classes, CD model, I just go into CD model. Here you can see what are the different source codes here. So terahertz channel.h, then directional antenna, then terahertz energy model, then medium access control, the MAC headers, macro access points, macro mode and nano mode. There are two kinds of modes. Anyway, we are going to see all the 6G when we do the third day or fourth day. So the nano model is there, then net device is there, then physical layer macro and physical layer for nano. So macro means it is working on a longer distance range. Nano means very shorter distance range for 6G, 6 gigahertz spectrum, 6G spectrum. For that, we are going to use that. Then spectrum propagation loss, signal parameters, then spectrum waveform, and UDP client, UDP server, UDP trace client, and traffic generator. So all these things are available for 6G networking. Everything is available in the models here. So this is on the model. Okay. Now I come back to, I go into helper classes. So you can see something helper classes here, CD helper. Now the helper classes, you can see these many things are there. Directional antenna helper, energy model helper, then simple terahertz helper, MAC macro access point helper, macro client helper, then nano helper, then macro helper physical layer, nano helper physical layer, UDP client server helper, and traffic generator helper. So all the helper classes will be available in the helper folders. So not only here, terahertz, in all the source code, it will be available here. This is helper. Next thing is, we do the research. First time when we start the research, our job is to go to the examples, make it run. Okay, how these examples are working, what is it all about? So that's where we go for examples, CD examples. Now, once we go for the examples, they have two examples, one for nano ad hoc, another for macro center. So that means in the nano mode, in the ad hoc networking for 6G, how an example is there. In macro mode, central controller, I mean, instead of the distributor controller in terahertz, how it works. So these are the two examples that we can start with. So if you are planning to start your research in 6th generation, this is the first two files you have to start with, macro mode and nano mode. After that, modify the source code so that you can understand your concept well and good. Okay. So this is on the model, that the contribution model. Now, this is the contribution is third party. I have make it compiled for NS 3.38. But what comes with the NS3 is this folder. Okay. So this folder, I just show that this is the place. It is very important. /home /Pradeep Kumar /NS all-in-one 3.38 NS 3.38. Now inside this, I have all my things running here. So now I go into source code CD SRC. So once I go here, I have these many applications. Now one example is I will go into AODV protocol. Okay, CD AODV. CD AODV. You can see again we have doc, examples, helper, model, and test. So these are the classes. Now go into the model mode. In the model here, we have AODV data packets, AODV ID cache, AODV packet.cc, routing protocol, main routing protocol source code will be here, routing table.cc, routing queue.cc, and neighbor allocation, and that's all. Header files and the .cc files. So this is how the way the source code have been written here. This is on the model. If you want to go to the helper classes, CD helper, you can see AODV helper.cc, AODV helper.h. Just only two files to help it. So everything comes inside the source code. We can able to use the source code. It is for reusing. It is a pre-compiled libraries. So all source codes we have pre-compiled. So pre-compiled means they have already readily it's compiled. You are just going to use the source codes inside your C++ applications. This is what this NS3 do. Okay. So for this, all these source codes are available in this folder. Okay. So this is the folder where you have all the source code CD SRC. Okay. So whichever way you like, you can able to use it. Now one example here is, let me go into the antenna. So there is a folder called as antenna, CD antenna. So if many of you are fascinating about this antenna, so we have no helper classes for antenna, but we have model. Okay, so CD model. If you go, now you can see that the antennas are, what are the different antenna models supported? General antenna model, cosine antenna, isotropic antenna, parabolic antenna, phased array antennas, 3GPP antenna model, and uniform planar array model. So these many antenna models are already supported by NS3. Okay, so cosine, isotropic, parabolic, phased array, 3GPP antenna model, and uniform planar array antenna model. So that means these are already pre-compiled, and for that we have angles also, angles.cc, and we have antenna model.cc. Now one example, parabolic antenna model, let me open it. So I need to open with a tool called as gedit. It is something like a text editor. We have a tool called as gedit, parabolic antenna model.cc. When I use it, okay, so this is my antenna model. Okay. Now you can see in the antenna model, parabolic antenna model, this is my type ID here for antenna model. And what are the different attributes? Beam width. Okay, by default, the beam width is 60. So the 3 decibel beam width degrees in 60 degrees. And another orientation is the another attribute. So one thing is a beam width, orientation, and maximum attenuation. Maximum attenuation is just 20.0, and the orientation is by default it is 0. So if you want to change, you can change the orientation in the source code where you write. So there are only 3 parameters of parabolic antenna: beam width, orientation, and maximum attenuation. Suppose I want to do a research on parabolic antenna, I want to add one extra attribute which is not there in NS3. Then you can, what you do is, you can use another model here. Just what you do is just Control C, Control V. Okay. So like this, you can add one instead of attenuation, I can add something else. So let's say one model is angles. Angle, the maximum angle of the antenna rotation. So let me use 30 degree. I can use like this. So maybe I'm just doing this, and here the variable name I need to change it as M angle. So this way, I can able to add one extra attribute for my parabolic antenna model. So this is how the way I can able to do my modification of my existing source code. Okay. Now this is for advanced users, those who are planning for it. But in these 5 days, I cannot handle this because everyone research idea will be different here. So, but this is the method I can able to do my modification. First thing is I run with existing examples. After I analyze it, try to change parameters here and there and try to see how my network works, how my antenna works, everything you do. After that, include something new and do your research. So this is we called as a research. And I'll just delete that. Okay. So this is one parabolic antenna model, what we are planning for. Okay. Now, one examples. We have to see the examples now. So examples you can go. Oh, actually antenna, there is no examples. Okay. Because antenna is only a aiding pattern. Only for the networking, there are examples, not for separate antenna. Because every network has some kind of antennas. Okay. Okay, fine. Now this is antennas. Now let's say I go with the propagation model. So let's say I'm going with propagation, CD propagation. Here you can see I have examples, I have model, I have test, and I have doc. Now let me go into model, CD model. Okay. Now you can see that what are the different propagation model here. So we have a propagation loss model there and propagation delay model also there. So you can see const 231 propagation loss model, ITU R1411 loss propagation loss model, then JX propagation loss model, then N loss over rooftop propagation loss model, then Kun 2300 megahertz propagation loss model, then Okumura Hata propagation loss model, probabilistic V2V channel condition model, Then propagation delay model, propagation environment, propagation loss model here, 3GPP propagation loss, 3GP B2B propagation. So these many propagation loss models are available in NS3. Okay. So in case if you are doing some research in propagation loss model or a delay model, you can you need to work on this particular folder. Okay. So for that, I want to check an example. Now you come back to the previous folder and we have something called as examples here. Now go to the examples. Okay, this is an example. So there are two examples. One is Jake propagation and main propagation loss.cc. So this is main propagation. Now let me open the main propagation loss.cc. So when I open it, here you can see it comes like this. So here it is. First thing is the propagation loss model. So X label, Y label. So X axis, Y axis. Then first thing is constant position mobility model. We create something. Then first thing is, okay, this is for GNU plot. Yeah, now first thing is, yeah, now here it comes. So here we have still, yeah. See, freeze propagation loss model is one thing. We collect it. And log distance propagation loss model. Then random propagation loss model. Then Jake's propagation loss model. And here again, Jake's here. Then 3-log distance propagation loss model. Then Nakagami propagation loss model. Then, okay, these many loss propagation model, they just plot it in GNU plot. So this is the source code which is given. Maybe I'll just execute it after some time. I will execute this propagation loss model code. Then you can understand how my propagation loss model is working. Okay. So this way I can able to understand the source code of it. So whenever I see the source code, I should understand what is this source code all about. So this is where my understanding lies. Okay. So now this is the propagation. Now these are the source codes that comes with NS3. Okay. Now let me go into one example called as, we have one examples folder. So in the SRC, see we have an examples. In NS 3.38, we have an example folder, CD examples. The first examples you can solve is here only. You can see channel models, energy, error model, IP version 6, naming, routing, socket, traffic control, tutorial, wireless, and UDP client. So these are the different things available in this. So first let me go into routing. Okay, so CD routing. Okay, now the routing, I have one example. There are so many examples there. Here I have something called as Manet routing compare.cc. I have one source code called as Manet routing compare.cc. Okay, so this source code I will be doing it here. Now PWD, I use which folder? Okay. Now I'll do everything here. Okay, now we are going to see, one example called as Manet routing compare.cc file, which is located in the following directory. So this is the following directory where it is located. Okay. Move this file to ns all-in-one hyphen 3.38/ns hyphen 3.38/scratch folder for execution. Okay. So move this file or copy this file. So I can say copy this file. Copy this file to ns all-in-one ns 3.38/ns 3.38 scratch folder. So all the files, if you want to run it, they have to come to the scratch folder. Scratch folder has extra permissions and extra modules, extra linkages to run the ns3.cc files or .python files. It has to move to the scratch folder. Okay. So all .cc files for execution have to be moved to scratch folder. Okay. So this is where we are going to move everything to the scratch folder. Okay. So now let FTP day 1. Okay. So now this is where I am going to move. So I can either use GUI to move or through command I can do. So for your understanding, I will go in the GUI mode. So now I have the file NS all-in-one 3.38, NS 3.38, then examples, the folder examples, routing, and we have one file called as Manet routing compare. So here this is the file. Right click, copy. You can see I'm just copying it here. Copy. Right click, copy, and go to NS 3.38 and scratch folder. Paste it here. Paste. So now this Manet routing compare.cc, I just pasted out here. Now this is what I am going to see for the next 1 hour. Okay. Actually, this is one project. This is one project, and most of the students across the world, they do for comparing 4 protocols. Okay. So what are the 4 protocols is? Okay. So this Manet routing compare is a comparison project for comparing 4 protocols, wireless protocols, namely AODV, DSDV, DSR, and OLSR. So these are the 4 things they are going to compare. Okay. So in many web in the world, there are many people they use this project. Okay, AODV, DSDV, DSR, and OLSR. Okay. Now what I'm going to do is in the next 1 hour, I'll be completing this project. Okay. So assuming that I know NS3, I know how to read a code, then I want to do this project. Just in 1 hour, I can able to complete this project. Okay, this is what I'm going to explain you. So I already have a video also on this. I'll share the video link also. Even this video link also, I'll be sharing it for the end of the day, so that today evening, if you have a time, you can go through this. Okay. So this way, I'm just going to it now. Okay, now I'm just opening this file. Opening this file now for explanation. Okay. Okay. So now here, now I am in this folder NS 3.38, gedit, scratch, Manet routing compare.cc. Now this is the file I'm just opening. Now opened here. Now this is what the file what I have. Okay. So you can see the total number of lines in this file is almost around 428 lines. The total number of lines in this file. Okay. Anyway, I'll just explain you everything is how it works. Before that, you can see in the top, they have given some explanations here about this. This example, you can see here. This example program allows one to run NS3 DSDV, AODV, or OLSR under a typical random waypoint mobility model. So we are using a random waypoint mobility model under for these 3 protocols DSDV. By default, the simulation runs for 200 simulated seconds, of which the first 50 are used for startup time. The number of nodes is 50. Nodes move according to a random waypoint mobility model with a speed of 20 meters per second and no pass time within a 300 cross 1500 meter region. The Wi-Fi is ad hoc mode with the 2 Mbps rate using 802.11b and a Friis loss model, Friis propagation loss model. The transmit power is set as decibel dBm. Okay, 7.5 dBm. Decibel milliseconds. It is possible to change the mobility and density of the network by directly modifying the speed and number of nodes. You can change the speed and number of nodes. It is also possible to change the characteristics of the network by changing the transmit power. As the power increases, the impact of mobility decreases and the effective density increases. So you can able to alter the transmit power also. The transmit power is 7.5 dBm. You can change it to 10 dBm also and just see how the performance varies. By default, OLSR is used. By specifying a value of 2 for the protocol will cause AODV. Specifying a value of 3 will cause DSDV. Okay, so we can use OLSR, AODV, and DSDV for all our work. By default, there are 10 source sync data pairs sending UDP data at an application rate of 2 MB per second. That is 2 kilobits per second each. This is typically done at a rate of 464 byte packet. That means 4 number of 64 byte packets per second. Application data is started at random time between 50 to 51 seconds and continues to the end of simulation. So total number of simulation is 200 seconds. You can see 200 seconds. Among that, first 50 is startup time, and after 51, it continues to the end of the simulation. Okay. So the program outputs a few items. Packet receptions are notified to STD out, and this is what. Okay. Now this is what the explanation of the source code. But anyway, I'll just go and then tell you the source code of how this is being written. Okay. So first thing is we have some header files which is included here. The header files are AODV module, applications module, core module, DSDV, DSR, internet module, mobility module, network module, OLSR module, and YAN's Wi-Fi helper. So we have a Wi-Fi also. So that's why we have a Wi-Fi helper. And FStream for file stream, IO stream for input output stream. Okay. Because we want to write something to the file output and we want to read from the streams also. That's why we use the FStream and IO stream. So these are all C++ objects. But please understand, again, I'm just telling, for you need to understand this. You don't need any source code to be written over there. Okay. So you need not write a source code right from the beginning. Already source codes are there. Only thing is you need to understand what is the code is all about. So once you understand it, then you can modify. Simple things you can modify. Even if you want to modify, upgrade something, you can able to do that once you start doing the codings. Okay. So now I have two namespace NS3 and DSR. So DSR have a special meaning. That's why we use a namespace. So namespace means something like this. For example, using, anyway, I just write down in this here. Using namespace, if I use VIT Chennai, okay, if I use like this, then whenever I say VIT Chennai dot FTP dot wireless dot, so let me take some name here. Someone is, let's say, first thing is Dr. Sivabalan, okay, dot Sivabalan, sorry. Okay, suppose if it is like this, every time whenever I want to use, I will be using like this, okay, namespace. Instead, what I do is directly I can able to use, if a namespace is there, I need not tell every time VIT Chennai, just only this thing. Okay, ftp.wireless.sivabalan means this ftp.wireless.sivabalan belongs to VIT Chennai. Okay, so this how the way I can able to refer every time. So this is the purpose of having a namespace. Okay, so again, one more example is, so I am Pradeep Kumar. So if I use VIT Chennai, if I don't use this, so let's say if I don't use this, then VIT Chennai dot Pradeep Kumar, VIT Chennai dot Vetri. Like that we have to write. So if I use namespace here and simply use Pradeep Kumar means Pradeep Kumar belongs to VIT Chennai. Vetri will belongs to VIT Chennai. So this is the why we write the namespace here. Okay. So NS3 means all the classes which you use in the source code will have a tag of NS3. But every time we need not write NS3. So to avoid that, we use it. Else, we have to use like this NS3 colon, double colon, let's say, YAN's Wi-Fi helper. Like this, we have to write every time. If NS3, if a namespace declared, simply write YAN's Wi-Fi helper PHY equal to new YAN's Wi-Fi helper. Like this. If NS3 is not there, then what you have to do is we have to use NS3 colon, then NS3 double colon. This is how the way we have to write the source code. So to avoid that, we use the namespace. Okay. So now the purpose of namespace, you might be knowing why we write the namespace here. So the namespace here is NS3 and DSR. Okay. There are two namespace. Okay. Now log component means when I want to do the logging, log means when it set the log files, then I need to know what is the name of the log file. It is Manet routing compare. So I'm just going for Manet is mobile ad hoc networks routing comparison. That's what I'm just doing. Okay, now class routing experiment. First thing is I have a class. So this is a C++ class and public routing experiment. This is called the constructor. See, one source code I'll just explain you completely. And in 6G also I will explain, and in flying networks also I will explain the source code completely, so that you will understand, okay, this is the source code analysis, and after that we can go inside for simulation. Okay, right. Now routing experiment is a constructor. So constructor and the class name will be having the same name. As we have studied in object orientation, the constructor and the class name will be holding the same name. Okay. Now void run. So we have a run function that uses number of sinks, transmission power, and CSV file name. CSV file name for sending the data to my CSV files. Okay. So I'm having command setup, integer argument count, and character argument vector. So this again, argument count and vector is very important in generally in C programming. It is very important. Maybe just to show you one small coding. Hash include std lib at h, then hash include stdio.h, then integer main int r given count character star argv. Sorry that I'm just writing a faster program. So I'll just name this file as file.c. I'm just naming it as file.c. And what I do here is integer a equal to a to I of argv of 1, int b equal to a to I argv of 2. Okay. Int c equal to a plus b. Printf c is %d. So comma c. Okay, I am just using this. So this is my coding. So what I did here is argument count and argument vector. See that I have not sent any value for a, b. So, but I am going to read the value from argument count of 1. I want to send it one value. Argument vector of 2. I want to send another value. The whatever value I am sending is character. Array means it is a string. But I want to convert the string into integer. Further, I use a function called as a to I. A means string, I means integer. So I want to convert into string into integer. That is allocated to A and that is allocated to B, two variables. Now C equal to A plus B. Whatever A and B holds, I am just sending to C and I'm printing the value of C. Now this is my program. Okay. Now once you understand this concept well, then NS3 or NS2 or any discrete programming you can easily understand. Okay. So now I'll just come back here. Open a new terminal. You can see I have a file.c. This is a file.c. Compile it. GCC file.c. Okay, no errors. You can see one file called as a.out got created. So this is output file which got created. Now /a.out. As I told you already, any file if you want to run from the current folder, you have to use a /a.out 6,8. I am just using two numbers 6,8. Now you can see C is 14. You can see 6 plus 8 is 14. Now when I want to say 6 plus 10, C is 16. Now 699. Now this is 17998. So what I am doing here is I am using a argument count and argument vector. Instead of changing this value every time, I just send the value through command line arguments. So this we called as the command line arguments. Okay, I am just sending the value. Else what you do is every time you change the value and then recompile the program. So you need to recompile every time the values are being changed. But here, no need of recompilation, just change the value here. No, but if you give empty value, it will say that a segmentation fault. But you need to give like this. Now 0.1, 0.2. If you say that, it will give 0 because it is only integer. I convert everything to integer, not into float. So it know only about the numbers. So let me use 100.96, 200.7. The value is 300. 100 plus 200 will be 300. Now this is we called as a command line arguments. Okay. So this program, this is what we have. Argument count and argument vector is used here. Okay. So this is the argument count and argument vector. So double star means it is a string character array. Okay. Now I have a packet receiving function. Receive packet. The parameters are the socket as a parameter. Here the address IPv4 address is a parameter, and then number of node. This is the setup packet receive. And check throughput. Now I want to compute the throughput of my packets. I want to have a function for checking the throughput. Then port number. So port number I want to use unsigned integer 32 bits. Then total bytes I want to calculate received bytes and total packets received. Then I want to use a CSV file name. For that I create one string file name. Number of things I want to use the number of sync nodes. Then the protocol name. So here the protocol name I want to use is AODV, OLSR, DSDV and DSR. These are the protocols I want to use it here. Okay. Then double MTXP means transmission power. Here it is 7.5 dBm. 7.5 dBm. Then trace mobility. You want to say no, the nodes are moving here and there. You want to trace the how they are moving. In that case, it's a Boolean variable. The name of the protocol that I want to select number 1, 2, 3, 4 like that. Okay. Now routing experiment, I'm just creating one constructor. Port number by default is port number 9. The total number of bytes to be installed initiated is 0. Received packet is 0. The name of the CSV file is manner routing output.csv. Now what I do is I'll just change it to vatchennai.csv. Now, okay, I'm just doing this vatchennai.csv. Then trace mobility false. I'm not going to trace the mobility. I make it as false. Initializing. Number protocol number 2 is AODV. Okay. Now what they have given here is, you can see here in the text here, OLSR is default, 2 for AODV, 3 for DSDV, and 1 for I think OLSR. I think. Let's see. We'll see what is that. So, but 2 means AODV. Okay. So now the print received packet. Whenever I want to receive one packet from, so received one packet from address, which node, who is sending the address, who is the sender address, and from where we are receiving. So this is the first one, receiving the packet from who, print received packet. So this code is about printing the received packet. Next thing is every time a received packet is received from the socket, it upgrades bytes total equal to packet of get size and packet received equal to plus equal to this thing. So what does it mean is equal to packet received plus 1. This is what it means. So packet received, whenever a packet is received, it will be upgraded with 1 packet. Okay, 1 packet, second packet, third packet like that, plus 1 will be upgraded here. So this is what the packet received logic means. Okay. So now routing experiment. So we have check throughput. So the throughput is computed like this. Okay, total kilobits per second is bytes, total bytes received into 8. That is converting bytes into bits, 8 divided by 1000. Because in bits per second now, it is milliseconds. I am going to convert it to seconds. Then that will be printed to the CSV file name. So in the CSV file name, that will be printed there. And that will be running for the check throughput. So this experimentation is, routing experiment is for checking the throughput. We are plotting the throughput values. Next thing is set up packet receive. So what kind of packet I am going to use? I am going to use UDP socket factory. So you know we have two kinds of packets. One is UDP, another is TCP in the transport layer. I am going to use UDP means no acknowledgement, simple to implement. That's what I am going to use it here. Okay. Now here we have command setup. Now I said that CSV file name, trace mobility, and protocols. Protocol you can see 1 means OLSR, 2 means AODV, 3 means DSDV, 4 means DSR. So this number you need to keep it ready. And every time when the CSV file name, we can convert the CSV file name. So this name also you can see trace mobility and protocol. So we are going to use these two, CSV file name and protocol. We'll be using it. I'll show you how that can be done. Now we use a CSV file name here. And this will be sent to this simulation second, receive rate, packet received, number of things, routing protocol name, and transmission power. All these 4 parameters will be sent. Number of things is 10 and transmission power is 7.5 dBm. That will be sent across. Okay. So the total number of Wi-Fi nodes is 50. So total number of Wi-Fi node I want to use is 50 nodes. If you want, you can use 100, 200 like that. Okay. So 50 nodes, 50 nodes or 100 nodes or 150 nodes like that. If you want, you can able to increase the number of nodes according to your comparison. So total simulation time is 200 seconds. So 200 is, if you think 200 is vast time, you can reduce that also. But let's see how the 200 thing works. The rate at which it does is 2048 BPS. So this means 2.048 kbps, kilobits per second. This is what it means. Okay. So the physical layer mode is I am using a DSSS radio model with a 11 Mbps. So this is nothing but 802.11b. And the name of the trace file is Manet routing compare. This is the name of the trace file. This also will convert into VAT Chennai. Okay. And node speed is 20 meters per second. Okay. So if you want to say 10 meters per second, how the parameter changes. If you want 20 meters per second, how it changes. If you want to use 30 meters per second, how it changes. You can vary that. Okay. So let me use 20. There is no pass time in the nodes. So let it be 0. The protocol name, variable name is protocol. Okay. Now we have the on-off application of packet size and data rate. So either full packet data rate or no packet data rate. So packet size is full or 64 or 0. So if 64 is there, the full packet size, 0 means no packets. Similarly, data rate is 2.048. This is the rate 2.048. If it is on-off application means either full or no data rate. That's what on-off application. Either 0 or 1. 0 means 0, 1 means 2048 BPS. Here packet size 0 means 0, 1 means 64. Okay. Then Wi-Fi remote station manager. So we just create one Wi-Fi because all the nodes are going to use Wi-Fi only. So for that, we use a remote station manager like a access point. So we create the number of nodes. Now you can see the first thing node container. Now recall our first class abstraction is node in NS3. First abstraction, we use node container. Okay, first abstraction we are using. Ad hoc nodes, the name of the variable is ad hoc nodes. Create totally 50 nodes. So we are creating 50 nodes here. 50 nodes. Because already N Wi-Fi we have created 50 here. So these are 50 nodes that we are creating here. Okay. Now standard is Wi-Fi standard 8.2.11b. We create one Wi-Fi helper classes. Okay. This is the Wi-Fi helper classes. So we call this as topology helper. Topology helper classes. We have seen. Okay. Then we have a physical layer and we have a channel here. Channel. So the second channel in NS3. So the node we have used and we have used the channel also in NS3. So node in NS3 and channel in NS3. And propagation delay is constant speed propagation delay model. That means what? Whenever you move in a constant speed, there will be a delay in the propagation. So that's what constant speed propagation delay model. And propagation loss model is frisk propagation loss model. So we just go for a frisk and create a channel path. So create a communication path with these available parameters. What are the parameters? My standard is 802.11b. I have a physical layer. I have a Wi-Fi channel established with a delay and a loss model. So using that, you create a channel. Okay. Then after the physical layer is done, we have to have a MAC layer. So medium access control. So on what speed the data rate. So here the constant rate Wi-Fi manager. That means all people in the room will have a same Wi-Fi speed. That means constant rate Wi-Fi manager. So under that we have two modes. One is data mode, another is control mode. And transmission power starting here is 7.5. Ending also 7.5. So we have starting and ending 7.5 dBm. So that means no loss in the decibels. Okay, 7.5 dBm. So on both the cases. Then for type ad hoc devices, it's ad hoc Wi-Fi. Ad hoc means there is no access point, but everything is based on ad hoc. All the nodes can talk to each other. So all Wi-Fi nodes talks to each other. So this is what ad hoc mode. So if it is an access point mode means you need to define one access point and some nodes that can talk to the access point. So it is infrastructure mode, but we are going everything in a ad hoc Wi-Fi MAC. Okay. and establish this ad hoc Wi-Fi MAC into the net device. Now you can see the net device here. Net device in NS3. So we have channel, we have net device, we have node, net device container. Okay. So this is a net device, we install it. So we install Wi-Fi 5, Wi-Fi MAC, and ad hoc nodes. So we install everything Wi-Fi MAC, and then this and this Wi-Fi PHY. Everything you install it on all the ad hoc nodes. Ad hoc nodes is totally how many nodes we have created? 50 nodes. There is 50 nodes we have created. For all the 50 nodes, we establish the ad hoc Wi-Fi MAC. Okay. So then mobility helper. Now how they are moving in a mobility fashion. So there we have using a position allocator called as a random rectangle position allocator. Okay. So that means I have a rectangular position. In the rectangular position, the nodes will move here and there slightly. They have a movement. So for that, I am using one rectangular position allocator. So x-axis here is 300. Y-axis is 1500. That means x and y is 300 cross 1500. The area, the work area. So that means all the nodes are positioned in 300 cross 1500. That means the x-axis is 300 and y-axis is 1500. So it is something like a rectangle. So the area is something like a rectangle. Maybe I'll just show you that. You can observe it. Just open the browser. Okay, whenever anything is asked like this, give 1, 2, 3, 4, 5, 6. Okay, so 300 cross 1500 rectangle. You can see it looks like this 300 cross. This thing is yeah, it is something like this. 300 this side and 1500 this side. So that's what 300 cross 1500. So in this area only we are going to make the nodes to move. Okay, just to make it 300 cross 1500 work area. Okay, now for in this position, and here I have the node speed is, we have totally node speed is 20 and minimum is 0, maximum is 20. We have a varying speed. That's why we use a uniform random variable, because one node will move at 0.3, one node will move at 20, another node will move at 10.3, 4.5, 7.9. But I want to give a min and max. The minimum is 0.0 and the maximum is 20 meters per second. Similarly, constant node pass is 0 only. So that's what I am using. And mobility model is random waypoint mobility model. So randomly they will move within the position allocator. So if I use a position allocator, they cannot move beyond the position allocator, but they can move in a random way fashion. So within 300 cross 1500, I can move, but I cannot go beyond 1500 in y-axis, beyond 300 in x-axis. That is what here the mobility model will do. Okay. Now that is done. Now we are coming into the AODV helper. AODV helper, AODV, OLSR, OLSR, DSDV, DSDV, and DSR helper, DSR. We have the 4 protocols: AODV, OLSR, DSDV, DSR. Okay. Now IPv4 list routing, internet stack. Now I use a switch case. In C programming, we use switch case algorithm here. So here the M protocol, if it is 1 means OLSR, if it is 2 means AODV, if it is 3 means DSDV, if it is 4 means DSR. So we have these 4 protocols here. And if any other number is there, it is no such protocol, because we are configuring only for 4 protocols: OLSR, AODV, DSDV, and DSR. If M protocol less than 4, then we use this. And if it is equal to 4, we use this ad hoc nodes. Because DSR, dynamic source routing, has a different mechanism. That's why for that alone, we have internet.install. But for less than 4, we have a routing helper. Because DSR uses a caching, but other 3 protocols, they don't use caching. That's why for caching, we use this DSR main. since they don't use cache, these 4 protocols, they don't use caching. So we use the center routing helper. Okay. Now we give for address helper. So for the, what is the IP address we want to allocate? So set base 10.1.1.0 255 this, and we go for UDP socket factory, and on off we are using on off helper untime constant random variable 1 and constant random variable 0. This is for UDP socket factory. This is what we are going to use. So number of sinks we already have 10. So as per the number of sinks, I am just sending the value start from 100 to 101. Okay, total time is 200 seconds. So this value is being printed over there, and that is a simulation. So finally it will be printing the throughput. So simulated destroy. After that we destroy the simulation and then we run it. So this is a simple example of AODV protocol. Okay. Now what do I do is I have 2 variable here. The variable name is, I'll just make a note of it. So one is CSV file name, another is protocol. This is what I'm going to use. I'm going to use OLSR, AODV, DSDV, and DSR. Now I have another 25 minutes time remaining. In the 25 minutes, what do I do is I will plot one variation between all these 4 protocols. Okay. So this is a Manet routing apart, which is there in the scratch folder. Okay, I'll just open the terminal. Okay, this is the terminal here. So to run any protocol. Okay, now I'll just come back here. To run a .cc file in NS3, here is the command. Command is, again, I'll just run from the beginning here. Open a new terminal. CD ns hyphen all in one hyphen 3.38 slash ns hyphen 3.38. Okay. Now here is dot slash ns3 space run scratch scratch slash. Now in this case, Manet routing hyphen compare.cc. Now this is the file we will be running. Okay. So CD ns all in one 3.38 ns 3.38. Now the command to run is, this is the command to run, dot slash ns3 run, and after that scratch Manet routing hyphen compare.cc. Now this is the file we are going to use it now. This is what we are going to run. So before that, move the .cc file to scratch folder and open a new terminal. Okay. So we have already moved it. Now we are going for a, okay. Now I am already in this folder now. Dot slash ns3 run scratch Manet routing compare.cc. You can see this is the command to run. Okay. Now first let me run it. For you also, whenever you do this program also, it will be exactly the same way it will run. You can see here 100.2627 received 1 packet from this, 100.511 7 node number 7 received 1 packet from this IP. Like that, you can go up to because the total simulation time is 200 seconds. But only after 100 only the packet started receiving. So up to 100 seconds, the network is idle. It is not doing anything. Only after 100, it works. Okay. So you can customize this as per your need. Okay. So now this is what we got up to 199.762. It stopped. Okay. Now when you check LS, I have seen that VAT Chennai.csv, VAT Chennai.mob, and this is where I have 2 files I got generated. Okay. Now I open both these files. So go to the terminal there. NS 3.38. Here I have VAT Chennai.csv. I just open here. Yeah, it's opening. It's getting opened. So what protocol we'll see it? You can see here. Simulation second 0, receive rate 0, packet received 0, number of sinks 10, AODV routing protocol. This is AODV. Transmission power is 7.5. Okay. Now see that up to 196, up till this we have this, but after 100 onwards, you can see the second parameter is receive rate and packet received. Okay. It changes. Up to 100, it is same. Because after 100, the simulation runs. Okay. So receive rate 10 AODV and this thing is same. Okay. You can see here, this is how the way the CSV file got generated. Okay. So this is on AODV. Now I want to run for DSDV and DSR also I want to run. Okay. This is only for AODV. Okay. Now I for that I'll do one small tweaking. Now let me use MOB also, MOB also. So this is a mobility position for each and every node. Okay. What time, what position the node moves. So this is the mobility. So totally 400 lines. Okay. So now what I do is I'll just go to the source code here. So I have CSV file name. I have protocol. So 1 means OLSR, 2 means AODV, 3 means DSDV, 4 means DSR. Now this is very important. And the name also CSV capital letter, file F small letter, and name is N capital letter. Okay. Now I am just running the same simulation one more time. 4 times I want to run. So /ns3. Now this is what very important. Run. Then using double quotes, scratch, Manet routing compare, space, double hyphen. Just come back to the source code, copy this CSV file name, copy. And already I have double slash here. I just pasted here. Anyway, I'll just run it over here. Just wait. So you can easily understand if I do that. Copy. To run the file for AODV, DSDV, OLSR and DSR, here is the steps. Okay. Okay. For AODV. Okay. So now what I do is, this is the command /ns3 run scratch Manet. So CSV file name equal to, now I want to use AODV. So I want to create a file name called as AODV.csv. Space. Then again I go back here. Protocol. Okay, I just copy this. 1 is OLSR, 2 is AODV. Okay, now 2 I want to compare. Okay, now double hyphen protocol equal to 2. 2 is for AODV. Okay, now close it. Now copy this. See the command name. So the command line argument is without recompiling, I am just creating the file name as AODV.csv and protocol is 2. That means it is for AODV, right? Anyway, I'll just run it. I click paste. Now this is for AODV. But we have to wait up to 200 because I have only 2 GB RAM. I have just fixed. So we have to wait up to 200. Anyway, I'll just plot also. Let's see how do we plot it. That's what very beauty of this. We'll plot the receive rate for all the 4 protocols. Okay. Yes, it is ending now. Done. Okay, now you can see we have one AODV.csv. Can you see this file? AODV.csv. Okay. So keep it like this. Now, one more time I need to do for what we have to do is for OLSR. For OLSR, the same command. Here instead of AODV file, I want to create as OLSR.csv. Protocol is, now this is where we have protocol is 1. So this number I want to make it as 1. 1. Okay. So now I compare this file, Control C. When I come back here, clear, right click, paste. Now see OLSR.csv protocol is 1. Now when I run it, yes, this is for OLSR. Yes. See that I have another file AODV.csv. I have OLSR.csv. Can you see? Two files got generated. AODV and AODV already created first time. OLSR second time. Now again I come back here. Now these 3 for DSDV, 4 for DSR. Okay. So now the same program, what I do is for DSDV. For DSDV, what I do is it is 3 na. So the protocol name is 3. And here the file name is DSDV. Similarly, for DSR, protocol is 4. But usually DSR sometimes misbehaves, but let's see. Okay, so DSDV and clear the screen and right click, paste. Now this is what DSDV. Nodes, and what is the difference between nodes and sync means? Nodes means the number of nodes participate in the simulation. Sync means number of destination nodes. I want to make which are the nodes who receive the packets only. So that is sync. Source to destination, that's what we are telling now. Source to sync. Sync means the receiving nodes. Out of 50 nodes, only 10 nodes receive the packets. Okay, that's what means. Okay, so now you can see this is for OLSR one file, AODV another file, DSDV also got created. Now finally we have this thing, DSR. Control C, clear the screen. Right. Okay, this is DSR. I think DSR takes a little bit time. Okay, at the end, there is some obsolete thing fallback. Anyway, no issues. DSR usually do that. Okay, now you can see we have AODV.csv, DSR.csv, DSR.csv, and OLSR.csv. Okay, so now let me open all these files from this SRC. From here, OLSR, open with Notepad. Okay, I'm just opening this file. Okay, so this is the file. I'm just opening it here. This is for AODV. Similarly, I can open all the other files, DSDV, DSR, and OLSR. All the CSV files I am just opening. Okay. So this is for DSDV and this is for DSR. Okay, and finally this is for OLSR. You can see automatically the name of the protocol is here OLSR, the name is DSR, the name is DSDV, and the name is AODV. Okay. Now second parameter is receive rate, and third parameter is packet received. Okay. So we have a variation in second and the third parameter. So second is this parameter and third is this parameter, 33, like this, the number of packets received. Right. Now I go, since 4 values are there, I want to have a comparison between all the 4. AODV, DSDV, DSR and OLSR. So if you know any comparison methods, you can try. How we can try is, wait, 199. Okay, this thing is, okay, one method is you can able to try Excel sheet. You can use Excel sheet and then you do the plotting. But I have NS3 has one GNU plot as one software. So I can write a small source code for handling this thing. So maybe it is easy for you. I'll just show you that. Set terminal PDF. I'm going to print everything in PDF. Okay. So, I mean, AODV and protocol dot plot. The name of the file is PLOT plot. That's what I am going to save it. Protocol dot plot. Okay. Then set output. The name of the file is protocol compare.pdf. I can say the name of the file as compare.pdf. Okay. So set X label. So x-axis is time in seconds. Set Y label. Y-axis is receive rate and packet received. There are two things here. Packets received. Okay. So then plot. So I need to plot. What are the parameters here is plot. First thing is AODV.CSV. This plot AODV.CSV. Which parameter is the first line you delete it because first line is a text line. So we'll have, okay, delete that first line, save it. And comma also you remove it because comma is also not command control H. Comma will be removed and instead of comma, you'll have a blank space, replace all. You can see everything removed. Okay. So similarly for DSDV, control H, replace all. Only this control H, replace all. Similarly this control H, replace all. First line alone I delete. The first line is a text line which I am going to process it. So how the method is easy. Okay, now first parameter is that is the x-axis. Second is the y-axis and third is also y-axis. First, second and third. I am going to use the first column, second column and the third column in all the 4 files. Because all the 4 files resemble the same thing. Only thing is the protocol is different. Okay, now what I do is plot AODV CSV using 1:2. 1:2 means first column is x-axis and second column is y. It is like x:(y). That's what first column will be x-axis, second column is y-axis with points. With only points. Title is AODV, comma. I use the same thing now. Copy here. One more time. So second time is 1:3 only, but instead of this now OLSR. OLSR, the title is also OLSR. Then here it is DSR, the title also DSR. So when this is DSDV. DSDV. Last comma I delete it. Okay. So this is first thing. It is receive rate. Okay. Now I will use this thing here. And same thing here. X label, Y label. Now I copy this again one more time. Second graph. Y label is now packet received. Okay. So instead of 1:2 now 1:3 because third column is a packet received. So, but all other thing remains same. Okay. So I have two graphs will be ready. So Y label, X label is common, time is seconds, Y label is receive rate, and here is also. Maybe if you want, you can use this also. Control C. Control. Okay. Now maybe here you can use set title. Set title as receive rate and packet received. Title of the graph. Okay. Now this is my code of GNU plot. So very easy. Set terminal PDF. I am going to use the terminal as PDF. The output of the file is compare.pdf. The title is this. X label. What is the x-axis? What is the y-axis? And plot is the command. That's all. Okay. Now I will be running this example. So GNU plot protocol.plot. Yes. No errors. Now I go back here. Here you can see compare.pdf. Now I got two graphs you can see here. AODV plus OLSR is this and DSR is this and DSDV is this. This is for receive rate and packet received title. And here it is packet received in the y-axis and x-axis time in seconds. Only after 100 only the simulation starts. Otherwise it isn't. But it is only points. I have given points now. That's why this error. Now what I do is I'll go back here. Instead of points, I'll say lines. Lines. Instead of points, I'll say lines. Okay, Control H. Instead of points, I'll say lines. Okay. Now I will run it again. Now you can see. Now this is the graph for receive rate and packet received. So this is 1:2. And okay, this is how the way up to 100 nothing happens because up to 100 there was no simulation. Only after 100 to 200 the simulation runs here. So AODV is a pink color, OLSR in green, and DSR in blue, and DSDV in this. So when you see that the maximum is AODV only. The receive rate is very high in AODV. You can see the maroon color. So if you want to increase the graph size, so if you want to increase title AODV, after that if you use line width 3, then everywhere you can use a line width 3. You do like this. Now again I run it. You can see this line width. You can see how the graph line width increases. So second thing I didn't do, but only with the first thing it is increasing. So now in this case, by seeing the graph itself, we can directly see that AODV have a better receive rate compared to the other thing. So in the y-axis, you can see the maximum thing, the DSR clocks is 24. At one point of time, it was at 160. It has 120, 24 obviously. But many times you can see around 20 AODV clock 2 times and around 16, 17 AODV clock multiple times. And but among the lowest performing is I think DSDV protocol. So DSDV is the lowest receiving rate, whereas AODV had the highest. Similarly, packet received also same thing. But packet received, you can see it is 50. The y-axis, the maximum is 50 here. And up to 35 to 40 that AODV and have received it. On an average, AODV did well, and that's what DSDV performed less compared to the other protocols. So this is the way we can able to generate graphs in the receive rate. Okay, so actually this is one project done by your PG students as performance comparison of wireless ad hoc routing protocols. But using this one file, you can able to do many results you can able to do. Okay. So now what I do is, now in this case, what they said is 7.5 dBm. I will go with some higher dBm. dBm, I will make with the higher milliseconds. dB, so instead of 7.5, I make it something, but again, I need to run for 4 times. Okay. So what do I do is I'll just close these files. Okay. In this close this file, so control F 7.5, I'll just check it 7.5. Oh, here transmission power is 7.5. So what do I do is I'll change it to 9.5. I'll just increase that to 9.5. Okay. Same 50 nodes here. So I'm not altering 50 nodes. So you can alter anything as per your wish. So you can do that. Okay. Now what I do is again I go back here. I just run all the 5 files again one more time. So first control C. Now my AODV.cc file also will change because now this is for new, dBm. Earlier it was 1.5, now it is 9.5. I can able to compare the old with the new also, that can able to compare. So this way I can able to do multiple results. Okay. So the time is 12 now. Maybe another 5-10 minutes I'll just take. Okay, this is AODV. Now next thing also I'll just say. Now that receive rate I will compare with the new receive rate. Okay. So for dBm, is there any variety? Is there any change in the dBm that will compare? But 200 is the highest point there. 200 seconds. That's why we have to wait for some time. Anyway. Some questions. Okay, it is done. Now next thing is OLSR. Next thing is DSDV. Okay. Next thing is DSDV. And finally, we have DSR. So if you have any queries, you please let me know in the chat box so that I can, or else I will give an example. You can try the same example exercise for you. Okay, now you can see this is an exercise. Okay, now this is done. In the meantime, I will just run this. I'll just explain you how that can be done. This is DSR. Okay. Now the exercise is in the Manet routing compare.cc file, in the same file what I worked now. plot the characteristics of AODV and OLSR alone. I have not used other two protocols. For the average receive rate when the number of nodes are 30, 50, 80, and 100. So that means now the number of nodes is by default 50. Now what you do is you just change it to 30, then one more time change it to 80, and one more time change it to 100. For that, take the running for AODV and OLSR for both the times. And then average receive rate means you compute the average value from the Excel sheet. From the CSV file, compute the average receive rate. Then plot. For 30 in the x-axis, 50, 80, and 100, what is the average receive rate for the number of nodes? You have to have two graphs. One is for AODV, another for OLSR. Now, this is an exercise. It very easily can be done. Okay, now still it is done. I will just show you another receive rate. I already have that graph. This graph, I keep it ready. And I'll plot one more thing also. Okay, now this thing I just keep it ready like this. Yeah, it is done. Okay, fine. So now Control O. I'll just open all the four files. AODV, DSDV, DSR, and OLSR. All the four. First parameter I did delete. Control S, Control H, comma, blank space, replace all. Save. Replace all. Control S, Control H. Replace all. Control S. Control H. Replace all. Save. Okay. So now again what I do is I'll open the protocol file. Control O, then protocol.plt, the plot file. Here compare means here it is compare to. I create one more file with the same data. So because everything is same only. Now let me run a GNU plot. Yes. Now it will create one more compare over to file. Now can you see here? Can you see here? Okay. So you can see now, this is the left-hand side is compared to is now recently what we have done. So we have increased the decibel, the transmission power to 7.5 to 9.5 dBm. For that, how the receive rate and packet received are affected. And the right-hand side, we have the decibel rate is dBm is 7.5. So for the 7.5 dBm, you can see how the performance. In the initial time, you can see the blue color, see it is DSR. In the initial time, see up to 100, immediately it clocks 20 receive rate. But here it goes up to 160. So because of the highest transmission power, it instantiates very high in the peak. So most of them are in the peak. You can see the AODV also how many times it clock its peak, and even you can see the orange color DSDV also. It has clocking somewhere around 14 in the compared to. In the compare one, it was nominal. So increase in dBm will increase the transmission power. So if you compute energy, then obviously you can compute the energy occupation will be more when the dBm is more. If it is less, when the dBm is less. So this way you can compare two graphs with receive rate and packet received. I have just done only packet receive rate, but we can able to compare throughput, flow, energy, everything we can able to do on this comparison. Okay. So this way we can able to compare our research, our Manet routing protocol or wireless communication protocol with the available results here. So I have not gone anywhere. The file is already there in NS3. Only thing is we need to use the file and make it to our discretion, and then we have to change it as per our convenience. Then we analyze it. So this is our second step. First step is to understand the code that we already done. Second step is run the code with the various parameters. That also we have done it. Third work is we can do some small experiments or something. So that I have given you. Fourth one is we can modify something. Okay, oh, this part is lagging here. Let me modify this protocol. That is for the fourth step. That's where we call that as a research. But till this time, we can able to do everything as per our convenience. Okay. So